Okay, so when we talk about natural selection, we often talk about it as survival of the fittest. And I think a lot of people interpret that to mean that the population will always be moving in one direction to become more and more fit. And I think we picture it on a graph as something like it moving in one direction. In reality, there's three possible outcomes to natural selection. We have stabilizing selection, directional selection, as well as diversifying selection. And I think when people think about natural selection, they, in their head, are picturing directional selection. So let's go ahead and talk about what each of these types of natural selection actually is. So in stabilizing selection, here we have directional selection. So in directional selection, which is what most people think of when they think about natural selection, is when the population's average phenotype is actually shifting. So here, if we had the mean of the population of moths here, you can see it's moving in a direction this way. So now the mean has shifted, and that would be directional selection. You may think about this in giraffes, for example. If over time a taller height was selected for, then over time the average height of the giraffes would get taller and taller and taller and taller. That would be directional selection. Or let's pretend that it was in mice living on sand, moving maybe out of a forest onto a sand ecosystem where maybe they were originally a medium brown color, and then over time a tan or light color fur was selected for. So over time it would gradually get lighter and lighter and lighter. Or if you talk about the little mice that live on lava rocks, where they get darker and darker and darker over time, those would be examples of directional selection, where the phenotype is shifting in one direction or the other. We also have what's called stabilizing direction. And in stabilizing selection, this is where the medium phenotype is actually favored and has the highest fitness. And it's the individuals that are in the extremes that are going to be selected against. So an easy example to think about would be in human births. So without modern medical intervention, if you think about human babies that are between 2 to 5 pounds, without hospitals, their chance of survival is pretty low. And on the opposite of that, think about large babies, maybe 10, 11 pounds. Without modern day C-sections, there's a good chance that they would be stuck in the mom's birth canal. So both the baby and the mother would pass away or would die during labor. So therefore, the small offspring and the large offspring are actually selected against, leaving the medium weight of 6 to 8 pounds being selected for. So here you have a stabilizing selection where the two extremes have low fitness, and it's the medium phenotype that has the high fitness. So over time, you would find the mean or the average of the population's phenotypes being closer and closer together. And then you have diversifying selection. So in diversifying selection, this is where the two extremes are favored. So we could take this example here. If you look at the mice, these are rabbits. If here the original population that's in blue ink, if this phenotype was selected against, and it's the other two phenotypes that are selected for, you would find a decrease in that medium phenotype, and then over time, the two extremes would be favored. You can think about this also in little pocket mice, where they have studied mice in lava fields. So if you have a sand environment and old lava rock that has that dark black appearance, and maybe you have a brown mouse here. So this brown mouse would be too dark living in the sand environment, but too light living in the lava. So therefore that brown phenotype would be selected against, and the sand or tan colored mice would be selected for, as well as the lava or dark colored mice would be selected for. So you have diversifying selection where the two phenotypes are actually the two extremes. So just another way to visualize it, we'll look at these four rectangles. So in stabilizing selection, if we have this starting population, I want you to think about, well, what will this look like? Well, in a stabilizing population, it's going to be the medium phenotype that is favored. So here, this will be favored. These ones will have low fitness. And over time, you should see, a greater amount having that medium phenotype by selection, survival of the fittest. Now, when we talk about directional selection, here you could have with the fur color, well, maybe you have, here's our wide range of variation to start with, and in one situation, maybe the lighter phenotype is favored, leading the graph to shift in this direction, and maybe in a different situation or a different environment, the darker phenotype is favored, causing it to shift in the direction to the right. So this would be an example of directional selection that we can think of with giraffes pretty easy. Or when we talk about the finches, during the drought years, how the larger beaks were favored, that would be directional selection this way. And then when the rain comes and the small seeds are more abundant, then it shifts back in this direction. So really, it's the context of the environment that's going to determine this directional selection that's occurring. And our last one, disruptive selection or diversifying selection, is when you have that medium phenotype is the one with the low fitness, so you get the two extreme phenotypes being favored, and you can see this in the pocket mice found in lava fields. Okay, so those are the three types of selection. Good job.